Hello friends and my dear students, I welcome you all to my channel. If you are not yet subscribed and you are watching my videos on regular basis and my videos are beneficial to you, then I will request you to subscribe to my channel, support me, and also please do not forget to press the bell icon so that you will be notified by my future video. This video is part of my playlist CBSE Mathematics Class 7 following the textbook of author R.S. Aggarwal. This is Class 6 on the chapter Algebraic Expressions, and the last class. In this class I will discuss about how do we multiply a binomial expression, a binomial with another binomial, that is an algebraic expression with two terms. We will discuss both the horizontal method, which is nothing but the distributive law of addition and subtraction, a distribution law of multiplication over addition and subtraction, and also using the column method, and we'll finally solve few problems from exercise 6D. So let's get started. Okay, so as usual I have my notes as well as the same canvas. I will discuss the concept and will solve the problems. So in this video we will discuss about multiplying two binomials. Well, it can also be trinomials, it does not matter. So let's say if A, B, C, D, E, F are algebraic terms or monomials, and then also let if B1 is the binomial A plus B. Since A and B are terms, algebraic terms, so A plus B will be a binomial. Similarly, let's say B2 equals to C plus D. So we want to find the product of B1 and B2. So B1 and B2 are two binomials. We need to find the product B1 and B2. Now the horizontal method says that you just use the distributive law of multiplication over addition and subtraction. So in this case, in this method, so B1 multiplied by B2 is nothing but A plus B multiplied by C plus D. And we have to use the distributive law of multiplication over addition two times. The first time we are distributing over the multiplication of A plus D over C plus D, so that becomes A plus B into C plus A plus B into D. Then again we will have to apply the distributive law of multiplication over addition while doing the product of A plus B into C and A plus B into D. So in this way we get AC plus BC plus AD plus BD. Now AC means A multiplied by C, BC means B multiplied by C. For example, you see we are multiplying two binomials, 2x plus 1 and another binomial minus x minus y, minus x minus 9. So what we are doing is we are first multiplying the minus x term with the binomial 2x plus 1, so that becomes 2x plus 1 multiplied by minus x, and then we are multiplying the term minus 9 with the binomial 2x plus 1, so that becomes 2x plus 1 multiplied by minus 9. So now we do the multiplication of it's a multiplication of a monomial and a binomial, which I have already discussed in previous video. So it becomes 2x multiplied by minus x plus 1 into minus x plus 2x multiplied by minus 9 plus 1 into minus 9. I hope this is clear. We have already discussed this in previous video while discussing product of a monomial and a binomial. If you have not watched my previous videos, I highly suggest that you please watch them first to understand the concept of multiplying monomial with a monomial and monomial with a binomial. So finally the result becomes, and then we collect the like terms, we add the like terms, and it becomes minus 2x square minus 19x minus 9. Now the same product of these two binomials in the column method works this way. You first write the one binomial, that is A plus B, and then the product is similar way as you do product of integers. So we have A plus B multiplied by C plus D. Now what you do is you first multiply C, you consider the second algebraic expression, which is C plus D, and you consider each term from the left so this is the first binomial expression, this is the second binomial expression. Now you consider each term from the left of the second binomial expression. So the first term is c, so you multiply c is a monomial, you multiply c with the binomial a plus b, it becomes ac plus bc. So you write ac plus bc. Then in the next row you multiply d, the monomial d, with the binomial a plus b, so it becomes ad plus db. So the first row is nothing but the result of c multiplied by c, the product of c and a plus b. The second row, row ad plus db is nothing but the product of d and a plus b. And then when you collect the terms of the two rows, that is ac plus bc, the first row, and the second row is ad plus db, from here if you collect all the like terms and add them, then finally you get the final result, that is ac plus bc plus ad plus db. This is the final result of the product of c plus d and a plus b. As an example, you see the same example, 2x plus 1 multiplied by minus x minus 9. So we multiply the term minus x with the binomial 2x plus 1, we get the first row, and then we multiply the term minus 9 with the binomial 2x plus 1 and we get the second row. Now we add all the like terms and we get the final result, minus 2x square minus 19x minus 9. So visually the column method is more favorable, it's easy to understand, but while solving problems for your school exams or other competitive examinations, but once you get familiar with the horizontal method, that is the distributive law of multiplication over addition and subtraction, you can use that as well. But in case if horizontal method if you find horizontal method to be difficult, then you can always use the column method. Okay, so that was it for the concept behind multiplying two binomials. Now here, instead of binomials a plus b, c plus d, it could be trinomials or multinomials, that is the algebraic expression can have 4, 5, 6 terms, it does not matter. The concept works the same way. So let's try to solve a few problems from the exercise 6D. So the first one is find the products. I will solve it both by horizontal method and the column method. So the horizontal method, I am in short writing HM for horizontal method. This is what? So we have 5x plus 7, product of 5x plus 7 and 3x plus 4. What I will do is, I will first multiply 3x with the first binomial. So that becomes 5x multiplied product of 5x and 3x plus product of 7 and 3x. So this becomes the product of 3x and the first binomial, that is 5x plus 7. Now I will compute the product of the second term of the second binomial, that is 4, with the first binomial. So that becomes 4 into 5x plus 7 into 4. So now we have to simplify the products. This becomes 15. X into x is x square as per the laws of exponents. I have already discussed in previous video. X into x is nothing but x square. This is plus 21x. This is 20x and this is 28. Now we will collect the like terms. The like terms are over here. The like terms are 21x and 20x. So we just add the coefficient of the like terms and it becomes 41x and plus 28. So this is the result using the horizontal method, that is distributive law of multiplication over addition. Now let's see the same thing, the same product using the column method. So we first write the first binomial, 5x plus 7, and then we write the second binomial, 3x plus 4, and we have to do a multiplication. Now we first, from the second binomial, from the left hand side term wise, we will take the first term, that is 3x, and multiply with the first binomial, and it becomes 5x 3x plus 3x into 7. This is the first row. This is the product of the first term of the first term from the left of the second binomial with the first binomial. So this is nothing but 3x multiplied by the product of 3x, that is the first term of the second binomial with the first binomial. Now in the second row we will find the product of the second term of the second binomial with the first binomial, and it becomes 5x. My software is running very slow, I have no idea why. Okay, so 5x into 4 plus 7 into 4. This is nothing but 4, the product of 4 multiplied by 5x plus 7. Now we have to add. We have to add all the terms and combine the like terms. So the first term is 15x square. From the first row, the first term is 15x square, the second term is 21x. From the second row, the first term is 20x and the second term is 28. Now this, after combining the like terms, adding the like terms, 21x and 20x becomes 15x square plus 41x plus 28. So this is actually the final row is the result, after adding all the like terms, is the result of the actual product, that is 5x plus 7 and 3x plus 4. Whichever method you find convenient, you can use it for finding the product. But once you understand the horizontal method, usually we find the product using the horizontal method, that is distributive law of multiplication over addition or subtraction. Over here the binomial terms are added. In some cases it could be the binomial terms could be negative. Okay, so let's solve the question number 25 now. Okay, let's do it. Horizontal method. The first expression is a trinomial, as we can see it has three terms, and the second is a binomial, 2 terms. So what we will do is, we will first multiply the first term of the binomial with the trinomial. So this becomes, okay, let's do it step by step. X square. So I am finding the product of the first term of the second binomial x with the trinomial, and now you can also think it this way. If you basically, the horizontal method is nothing but distributing the multiplication over addition. So you see that if you consider this whole thing as a, for the time being, just for the sake of understanding and discussing, I am considering this whole trinomial as a. So following the distributive law of multiplication over addition, this is nothing but will be a into x plus a into y. So now if I substitute the trinomial, substitute a with the trinomial, this is x square minus xy plus y square into x plus x square minus xy plus y square and y. So now these two terms becomes, the first term is not term, the first expression is a product of a monomial, that is the x with the trinomial. So we know how to do it. This is x square into x, that is x cube. Then we will multiply x with the minus xy, that will become minus x square y. Then we will multiply x with y square, that is x y square. Now it's better to use parent grouping as long as for better readability. So if we now multiply the monomial y with the trinomial, it becomes, we will multiply y with x square, that is x square y, then we will multiply y with minus xy, that is becomes x minus xy square, and then we will multiply y with y square, that is y cube. So now we can remove the grouping because in front of the grouping there is no negative sign, both are positive signs. So we can now remove the grouping symbol. So this becomes x cube minus x square y plus xy square plus x square y minus xy square plus y cube, and now we have to add all the like terms. So x square y minus x square y and plus x square y are like terms, and since they are of opposite sign, they get cancelled. Also xy square plus xy square and minus xy square is also like terms, but since they are of opposite sign, they also get cancelled. So we are left with x cube plus y cube. So this is the result. Now I will show the column method for this problem only, but for the next problems I won't do the column method. I hope you will understand. How many problems are there? Okay. So for this problem only I am showing the column method. So while I am solving the problem, you can pause the video and take a screenshot for your reference. So in the column method, what we will do is, we will first write the trinomial. You write, when you are finding the product of two binomial expressions, two algebraic expressions, first you write the expression which has more terms, and then you write the expression that has fewer terms. So in this case the trinomial has more terms, so we are writing it first, and that below it we are writing the binomial. So we will find the product using the column method. What we will do, we will from the binomial we will consider terms from the left, one by one terms from the left hand side, and we will find the product of that term with the trinomial. So first we will find the product of x. The first term in the binomial is x. We will find the product of x with the trinomial. This is x square minus xy plus y square. So this is nothing but x product of x and the trinomial x square minus xy plus y square. In the second row we will find the product of the next term, that is y, with the trinomial. So this is y x square minus xy plus y square. So this is nothing but y square, y multiplied by the trinomial, Okay. Now if we do the product and add, we have to do the product and add. From the first row we get, if we do the product of the monomial x with the trinomial, we get x cube minus x square y plus xy square. This is the first product, and from the second row it becomes y x square minus x y square plus y cube. This will be the result of the final result, that is x plus y multiplied by the trinomial x square minus xy plus y square. Now finally we will add up the like terms, and we see that as before, x square y minus x square y and positive x square y gets cancelled. Also positive x y square and minus x y square gets cancelled. So we are left with x cube plus y cube. Okay, I hope you got the idea how we are doing product of two algebraic expressions using the column method. Okay, now let's do question number 9. I will not do the column method, but I will do the horizontal method, that is using the distributive law of multiplication over addition or subtraction. So I am considering, so let's so I am considering this as A, and I am considering this as B minus C. So it is of the form A multiplied by B minus C. After distributing the multiplication over subtraction, this becomes A multiplied by B minus A multiplied by C. So this becomes A multiplied by B is 1 by 5x plus 2y multiplied by B is 2 by 3x minus A multiplied by minus y. C is C is y. Sorry, C is y. So there will not be any minus y. It will be only y because we already have the minus over here. So this becomes, now we have to do the product of 2 by 3x with the binomial x by 5 plus 2y. This becomes 1 by 5 into 2 by 3 into x square plus 2y 2 by 3. Let's do it step by step, and this was actually, instead of writing this way, let's do it a little more step by step for better understanding. So this is 1 by 5x multiplied by 2 by 3x, and then we have y multiplied by 1 by 5x and y multiplied by 2y. Now actually this is when you are finding the product, this product we are finding this product, and before that we have a negative sign, so it's better to keep a grouping symbol, and this will be plus, because over here this is x by 5 plus 2y and product of y and x by 5 plus 2y, and before that we have minus. So I have kept a grouping symbol for the product of finding the product of y and x by 5 plus 2y. So we have this. Now if we simplify the product of the monomials, it becomes 1 by 5x multiplied by 2 by 3x is nothing but 2 by 15. We multiply the coefficients 1 by 5 and 2 by 3, and x into x is x square. Similarly, the second one becomes 4 by 3 and xy. We have negative sign, and when we do the product inside the grouping symbol, it is xy by 5 plus 2y square. Okay, now this is 2 by 15 x square plus 4 by 3 xy. Now we have a grouping symbol, and before the grouping symbol we have a negative sign, so we have to change all the signs of the terms inside the grouping symbols. So xy by 5 will become minus xy by 5, and 2y square will become minus 2y square. So now we have to see, there are two like terms, 4 by 3 xy and minus xy by 5. So we have to add them and keep the other terms unchanged, unlike terms unchanged. So we have 2x square, 2 by 5, 2 by 15 x square and minus 2 by y square. These are unlike terms, and we have to add the like terms, and this becomes 4 by 3 minus 1 by 5 into xy. Now this is 2 by 15 x square minus 2y square, and 4 by 3 minus 1 by 5, how much it is? 20 minus 3. 20 minus 3 is 17 by 15 xy. So this is the result. You can pause the video and take a screenshot for your reference. Okay, let's do question number 23. We are having a product of a binomial and a trinomial. So let's say for sake of understanding and discussion, let's say this trinomial is A and this one is, let's say, B minus C, where B is x square and C is 3. And so we see the product is of the form A multiplied by B minus C, which is nothing but A multiplied by B minus A multiplied by C. So this becomes A multiplied by B is 9x square minus x plus 15 multiplied by B. B is x square, and then we have minus. It's better to use grouping symbols for better readability, and then we have to do a product C, that is the trinomial multiplied by C, and C in this problem is 3. Okay, so now if we do the product of x square and the trinomial, it becomes 9 x to the power 4 minus x cube plus 15 x square. We have minus, and then if we do the product of 3 and the trinomial, it becomes 27 x square minus 3x plus 45. So now we can open the first grouping symbol because there is no negative sign in front of it. So it becomes 9 x to the power 4 minus x cube plus 15 x square. Now the second grouping symbol in front of it, we have a negative sign. So we will have to change all the sign of the terms inside the grouping symbol, the second grouping symbol. So 27 x square becomes minus 27 x square, minus 3x becomes plus 3x, 45 becomes minus 45. Now we have to see if we can add. There are two like terms, 50x square and 27x square. So 9x to the power 4 minus x cube, and if we add the like terms 15x square and minus 27x square, it becomes 15 minus 27 x square, and we have the other unlike terms plus 3x and minus 45. So this is finally 9x to the power 4 minus x cube minus 12 x square plus 3x minus 45. So this is the answer. Okay, I hope you are understanding the process, how I am applying the distributive law of multiplication over addition and subtraction. If you have any difficulty in understanding any steps or process, please do let me know in the comment section. I will appreciate that and I will do my best to help you out. Okay, this is a simplification problem, question number 31. So simplification problems are where you will have to add or do product of algebraic expressions and then finally simplify it by adding the like terms. So we see there are two products. First product is a product of a binomial and a trinomial. The second one is also a product of a binomial and a trinomial, and then finally there is a subtraction. Okay, so by using the distributive law of multiplication over subtraction for the first product, this becomes 3x square plus 5x minus 7x multiplied by the first term of the binomial, that is x, and since there is x minus 1, it will be minus again the trinomial multiplied by the second term of the binomial, that is 1. It's better to keep it in a grouping symbol. Now the second one becomes x square, the trinomial, multiplied by the first term of the binomial x, and since it's x plus 4, we will have plus x square minus 2x plus 3 again multiplied by 4, the second term of the binomial. Okay, so now if we do the products, we have 3x cube plus 5x square minus 7x, and let's keep it in a grouping symbol for better readability. And this one becomes, it is the same because we are multiplying by 1. So 3x square plus 5x minus 7. Now for the second grouping symbol, we have to multiply x with the trinomial, that becomes x cube minus 2x square plus 3x, and then we have we multiply 4 with the trinomial, that is 4x square minus 8x plus 12. Okay. Now inside the square bracket, first square bracket, we can, the first grouping symbol, there is no negative sign, so we can open it without any problem. 3x cube plus 5x square minus 7x, but the second grouping symbol, there is a negative sign, so we have to change all the sign of the terms inside the grouping symbol. So 3x square becomes minus 3x square, 5x becomes minus 5x, and minus 7 becomes 7. Similarly, if we do for the second square bracket, this is the first grouping symbol, will open without any problem because there is no negative sign just before the grouping symbol. Also the second grouping symbol will open up since there is no negative sign. So we have this. Now if we further simplify the two algebraic expressions in the two grouping symbols, we have like terms. For the first grouping symbols, we have like terms x square, that is 5x square and minus 3x square. These are one grouping symbol, and another one is 7x, minus 7x and minus 5x. So if we add them, we have this 3x cube. If we add the terms, like terms, 5x square and minus 3x square, we have 2x square. And if we add the like terms, minus 7x and minus 5x, we have minus 12x, and finally we have 7. Similarly, for the second grouping symbol, if we simplify the expression inside it, we have x cube, we have the like terms minus 2x square and 4x square, that becomes 2x square, and we have the like terms 3x and minus 8x, that becomes minus 5x, and the constant plus 12. Now we will have to open up the grouping symbols. The first one will open up because it has no negative sign in front of it. So 3x cube plus 12x square minus 12x plus 7, but the second grouping symbol in front of it, we have a negative sign, so we will change all the signs of the terms inside it. So x cube will become minus x cube, 2x square will become minus 2x square, minus 5x will become plus 5x, and 12 will become minus 12. Now we again have to see if we can combine any like terms. So we have like terms 3x cube and minus x cube, that becomes 2x cube. We have the like terms 12x square and minus 2x square, that becomes 10x square. We have the like terms minus 12x and 5x, that becomes minus 7x, and we have to uh, add up the constant, that is 7 minus 12, that is minus 5. So this is the final simplified algebraic expression. You can pause the video and take a screenshot for your reference. Okay, let's do question number 27. This is also a sum of two products, and the products are product of two binomials. So for the first one, it is better to keep the two products in another grouping symbol. So now when we are doing the product of 3x first product, that is the binomial 3x plus 4 and 2x minus 3, we first we first multiply the first term of the second binomial, that is 2x minus 3. Second binomial in the first product, the second binomial is 2x minus 3. So we multiply the first term of the second binomial with the first binomial. So 3x plus 4, 2x, and since it is 2x minus 3, there will be negative 3x plus 4 into 3. So using the distributive law of multiplication over subtraction, we have this. Similarly, for the second product, it will be 5x minus 4 multiplied by x plus 5x minus 4 multiplied by 2. Now if we do the products of the monomial and the binomials, we have 3x plus 4 multiplied by 2x, it becomes 6x square plus 8x, and the second one becomes 9x plus 12. Always use grouping symbols for better readability. In that way, you will chances of making mistakes will be very less. So we have this. Now similarly, we do for the second square bracket, simplify the expression inside the second square bracket. So we have to multiply first x with the 5x minus 4. This becomes 5x square minus 4x, and again we multiply 2 with the binomial 5x minus 4. This become 10x minus 8. Okay, now we have to simplify it further. Inside for the first square bracket, the first grouping symbol will open up because it has no negative sign in front of it, but the second grouping symbol, that is the expression 9x plus 12, in front of it there is a negative sign. So we will have to change all the terms, sign of the terms inside it. So this 9x becomes minus 9x and 12 becomes minus 12. Similarly, we do for the second square bracket. It is 5x square minus 4x plus 10x minus 8. And now we collect the like terms of the expressions in both the square brackets, in both the grouping symbols. So the first one, we collect the like symbols 8x and minus 9x. We add the like symbols 8x and minus 9x, that becomes minus x, and we have this. And for the second square bracket, we add the like symbols, like terms minus 4x and plus 10x. This becomes plus 6x minus 8. So now we can remove the grouping symbols because there is no negative sign in front of them. So this becomes 6x square minus x minus 12 plus 5x square plus 6x minus 8. Now we will have to add the like terms. So the like terms are 6x square and 5x square. If we add them, it becomes 11x square, and the like terms are 6x and minus x. If we add them, it becomes 5x, and finally we have to add the constant, that is minus 12 and minus 8, that is minus 20. So this is the answer. Okay, so that was the last question. I hope this set of questions will help you understand how we do the product of or to binomials, or in fact a binomial with trinomials, or in fact a product of two algebraic expressions where any one of them can have 4 or more, 3 or more terms. I hope this video was beneficial. If it is, then please like it, share it with your friends, and once again please support me by subscribing to my channel if you are not yet, and also please do not forget to press the bell icon so that you will be notified by my future videos. So this brings end of the chapter algebraic expressions as far as discussion of theory is concerned. Now I will prepare two test paper, practice test paper. I will from where the questions will be taken from external source, not from the textbook, and each test paper will have 20 questions, and we will try to solve it in 30 minutes. So I will prepare two practice papers that will give a good provide a good practice on the chapter algebraic expressions, and then we can move on to the next chapter. I think it is solving linear equations in one variable. So stay tuned for the next two videos, that is practice test paper 1 and practice test paper 2 on the chapter algebraic expressions. It will be very important for you to solve it. That will help enhance your understanding of the concept on the chapter algebraic expressions. So thanks for watching, and until the next video, take care and bye.